Tonight on Rubber Duck Engineering, we will continue our adventures in Rust, building a Wren compiler. Except tonight we're going to profile and optimize said Wren compiler. Hello, Dr. Barth.
Hi, Eric. So we're going to make it go fast.
We're going to make it go fast.
Now that we've passed 50% of the tests, now we're going to pass them really, really fast.
Oh, yeah. I don't even remember where we left. We were making maps work, right? Last episode?
That's right, yeah.
And then you and I made them work in like 5 minutes later in the green room.
It's always like that. It's always like when you take the pressure off, when the lights go dim, then you're like, okay, actually, you just got to put a semicolon right there, and then everything's cool.
Basically. So we made maps work, and that didn't pass half the tests. But then I passed half the tests, on Saturday or whatever when I was hacking on it. And we're actually way past half now. We're at like 500 versus 300. I mean, the numbers go down on one side and up on the other side. So every time you make one pass, you get two closer to being half. But yeah, so we made some significant progress. And then I kind of hit a wall this last weekend. I was a little renned out, but I got excited about things preparing for today's show.
I feel like you've had a ton of energy for this project. I've been sort of just amazed at like how much progress you've made on it. And so I'm not surprised that you want to take a break and put it down and maybe follow up on some other hobbies of yours. Yeah.
Well, July 4th came along, and I don't know, vacation, seeing family, all that was a good excuse to do other things. But for tonight, I actually got really excited again, and it helped, I think, to have a purpose. And I was making the benchmarks work. And then once I got the benchmark, that required me to do things like I had to fix string interpolation, which it turned out wasn't that hard, and fixed like 20 more tests because they were required for the benchmarks. But tonight we're going to do profiling and so benchmarking, which, as I said, I got working just today before the show, profiling, and then some optimizing. And I think when we look at the profiles, it'll be pretty obvious.
And you've built and run like the C version of Wren and also benchmarked it on the same hardware.
I did. And so I can actually show, it may
I'd love to see like where are we relative to C as our starting point?
So if we look, if we go to the code machine here, so the authors of Wren, probably Bob, wrote this little util benchmark script, which I got working. I forked it because it needed to be modified a little bit for Wren Rust. But it can run for different languages, and it can just run all the languages and compare them. But if you look at Wren C, it says like all these tests take on average like less than half a second. And Wren Rust is a different story.
Maybe more than a second, shall we say?
Yes, like Fibonacci takes 10 seconds to run. So we have a little bit of work ahead of us, and Python is a little bit slower. And like this script, I'm not going to run the whole thing because Wren Rust makes it take so long.
Is Python that's the same algorithms but implemented in Python what is the Python version here?
So if we terminate the batch job, if we go and look at the actual, so in the Wren C directory, inside test, there's a benchmark directory. And then the Wren folks wrote like a Wren implementation, and then so like this is the Wren implementation, this is the Ruby implementation, this is the Python implementation, this is the Lua implementation.
Oh, that's really neat. So then you can like compare and see like the same structure program running on different languages. That's really neat.
Yeah.
I know Delta Blue is a famous one. I remember that when back in the day when people were banging on JavaScript VMs, Delta Blue was always one of the ones they looked at. It's a big like it's some kind of simulator, I think, or constraint solver or something, but it's different from a lot of the other ones because it has a lot of heap and objects running around, whereas opposed to many of the other common benchmarks just end up being like number smashing.
Yeah,
like Fibonacci is mostly number smashing.
So if you look at the benchmark, whoops, this is I think the wrong one. Yeah, this is the wrong one. So I have a fork of the benchmark for a couple reasons. One of them is that I had to turn off a bunch of the benchmarks. So if you look, some of these are like, so like map numeric. I don't know. I let it run for several minutes and it never succeeded. So maybe once we fix the obvious low-hanging fruit, we'll be able to run that one. But like we're missing supercalls and fibers and stuff.
This was a big problem actually early on in Fuchsia. We wrote a bunch of benchmarks early on, but the system was so unstable that the benchmarks really were more like a correctness test for the system. Like, could you actually execute the benchmark?
Yep.
And so now all of our benchmarks in Fuchsia, we have both the correctness version of them that checks that the system works and the performance one that spits out like how fast did it go.
Yeah. No, I've actually been avoiding pulling up the benchmarks because I felt like it was premature to benchmark the system when it was still. You talk about how it's sort of like it's cooling still. The system has a lot of growing even to do. So I did a bunch. Like I completed basically all of core since we last talked. I upped my macros a little bit more. I copied in all of the pieces. So basically, you can walk through this class, and once all these comments are gone, the entirety of core is implemented.
Oh, wow.
So like all of num is now done. There's like a few things. There's a few things missing here and there, but really it's mostly done. Core. Also Wren core. I think we were hacking some on. Now almost completely works. Oh, the stub Wren core. Sorry, this is almost identical to Wren core. It's missing two. It was missing two things. One of which was the string interpolation, which I did this evening right before the show. Which actually unblocked some of this. But the other is forward declarations of modules. And once I do that, then we'll just be able to take Wren core stock.
Wow, that's amazing.
Anyways, to get to the part of tonight, so we run a bunch of benchmarks and we're terrible at them.
So what do we do about it, Eric? Like you've written all this big pile of code and it's slow. Should we throw it all away?
So I think it would be interesting to show what the sort of so to go back to thoughts about how I wasn't profiling. One of the things that you hear a lot in computer science everybody talks about how like the ultimate evil is premature optimization. And having been there, done that, I will tell you that I agree with that. The ultimate evil in computer science is premature optimization. So you really don't want to do it too soon.
But
I do think we're far enough.
Like there's also a stage where it's too late, where your system is basically cooled down and solidified, and now you're like, oh, really? To make this go fast, I have to turn it on its head and spin it around. So
exactly,
it's really an art to figure out when is the right time to bring in the benchmarks and what to do with the information.
Yeah, because the benchmarks are actually really useful once you lock them in as results, so you can see from commit to commit, or am I getting better? Am I getting worse? And we've been flying blind, but I don't think that was what I was going to say. Anyways, so I spent some time last night and tonight right before the show trying to figure out how to profile on Windows, because it's been probably a decade and a half since I've had to do that, since the beginning of the Chrome days. But I did find a thing. Let's see. And I think I should be able to, yes, very sleepy CS. This is a thing that will know how to profile. I installed 3 different profiles, but I got this one working. And if we run it, it knows how to launch things. Ooh, it does not deal well with scaled UI, so you can't really see this very well.
But it's basically telling it to run is it one particular benchmark you're running?
Yeah, we can run whatever one you want, but I just picked. Whoa, what is this doing?
It's analyzing all of the Dart code.
Oh, yes.
It's discovered that there's Dart code hidden inside your project. And it wants to tell you that it's not null safe.
The Dart code is all busted. It was so funny. You can tell that someone hasn't been working on the Wren project in a pushing. Well, I don't wish to. There's 100 plus people in the Discord. It just doesn't have the feel that someone has touched all of the code recently. There's definitely eddies of the code that just haven't been touched in years, and the Dart code benchmarks is one of them. As you see, they don't even compile anymore. So we're not doing Dart tonight. Sorry, we were going to run one of these benchmarks.
Yeah, I'm just curious which one you were running. If we could look at the code to see.
Looks like it's binary trees. Binary trees Wren. What is this doing? ported from the Python version.
Okay.
I think fields work. I'm pretty sure they do. So this should work. Oh, I had to implement system clock in order to make this work, which it turned out is a little awkward in Rust. C string interpolation.
Okay, so it's like messing around with the trees, maybe doing like a binary search or some kind of tree traversal. Okay.
Yeah, I haven't really looked at the. Anyways, when we run the profile, it will be very obvious.
Okay. You baked the profile in your other oven?
Well, I just ran it once because the difficulty for me was, so there's two types of profiling that I have commonly used. I'm sure there's other types for software optimization. One of which is like a tracing profile, which is like dtrace or strace or something like that, or Chrome tracing. The other is a sampling profile. And sampling profiles are really only useful for this kind of like micro optimization. Mm-hmm. The tracing one is much more useful for like long running things, or you're dealing with startup of an entire system. And I found all these Windows tools that were designed for like, how does my machine boot? And not like, I want to optimize the while loop in my driver, or something like that. I couldn't find that profiling tool, but I did find this one that'll do sampling CPU profiling. Anyway, so when we run it, so you can see this is the Wren, this is the output from the Wren. But it doesn't matter, we don't have to actually run it very long. Just go back to sleepy, and we stop. Oh, I did have to do a couple things to make these symbols show up. So I did have to edit my TOML, my cargo TOML, to tell my release mode to keep debug symbols. Just in case you're trying to do this at home. And I did then, of course, have to build these things. So it's like cargo build -- release.
Yeah, definitely do not want to profile debug code. That's a giant waste of time.
Yep. So this thing now shows that our top thing is alloc and free on the heap.
Okay, as usual.
That is also as usual, and it doesn't really surprise me. And this is, so I don't know this tool at all, but just having used a bunch of tools like this, my guess is this is sort of like,
this is a bottom-up profile, or this is just like a hot symbol list?
This is a hot symbol list, yes.
Okay.
And I think we can take one of these here, and there's this averages thing, which I haven't fully figured out, but you can look at call stacks, see where it's called. You can look at this, be like, oh, it's called from a format function. Okay, so fine, we're creating a string. You can see what the source file is and what the line is. So VM RS 780, I think it was. Nope, that's clearly not it.
760.
760? This thing. Method
not
found.
found. So that means we're trying to call a method that isn't there.
Well, let's see where this is called.
Oh.
Can you spot the error?
Yeah. Okay, so let me see if I understand this. So you try to get the symbol, and it's going to either be okay, or if it's not going to work out, we eagerly compute the error that we're going to throw.
Correct. And I think I knew this when I wrote this. Go ahead.
Yeah. Instead, what we want to do is we want to put that in a closure or something, so that we only create the error string when we actually have the error. Yeah.
I think okay or is a bit of a foot gun, unless certainly if you're calling anything. Because of order of operations, it has to evaluate this in order to pass it to the okay or function.
Yeah, it's very different from the or that's like the two vertical lines, which has magic evaluation semantics to only evaluate one side of it.
Yep. Anyway, so it's eagerly evaluating this. So basically, every time we call anything, we are doing whatever this method not found does, which it does a lookup of a name, which copies the name, I think, and then it does a format,
Oh boy.
Percent copies the string. So like we're just allocating not a billion, but like we're probably allocating 5 strings for any call.
Okay. I have my editor. Should I try to fix it?
Yeah, I hadn't thought through how to fix this, but
it's quite easy to fix.
I think we just
go
for it.
Oops. Sorry, I was just using my Linux computer earlier today. I started applying Linux shortcuts.
Oh my goodness! I now have a Mac that I'm able to use for work. I'd been stuck on a Chromebook for most of the last year.
Boom.
Oh, okay. I would actually probably have done it with like this, something like let method, like maybe method, and then dealt with that. But that works too.
And we probably should go through this whole function and use the or else. Like the same thing here, right? Like,
sure. I mean, I definitely thought about this some when I was writing this. I mean, in general, you don't want to, again, prematurely optimize, but you really don't want to be eagerly allocating copying strings, which is exactly what this is doing.
I mean, this is also sort of eagerly creating this closure.
Well, that's where so say we did this, right? So maybe method, and we do if, how do we want to do this? Maybe method is done, and throw that way.
Yeah, I mean, now you're getting sort of like the trade-off of like, how ugly do you want to make it? Like, what I would do in this is I would like know that this function is very hot, or this case is hot. Do this first level of thing, and then reprofile, and then see like how much of malloc, like what percent did malloc change in the profile? Can you save these profiles?
So let's save as. So this is with or else. I don't know if this has like any fancy comparison.
Yeah, I've used much like very fancy tools both on Mac and on Linux for manipulating and comparing profiles, which is very helpful when you make these sort of.
Source here.
Oh, that's cool.
Honestly, I got here by like searching Reddit for like how to do Rust profiling on Windows and people giving their various solutions. And one person was like, "Oh, you open up Visual Studio Code and tell it an empty C++ file, and then the like profiler thing on the side you can like attach from." I was like, okay. I actually kind of got far enough to make that kind of work. Somebody else was like, "Oh, you install this Windows." I have it installed. It's like the Windows. It's just like profiling test suite. But I like ran it, and it's clearly designed around like you hand this out in the field, and somebody like runs a profile, and then they like send it to somebody else, and then they analyze the profile. It's designed for like whole system profiling. So I gave up on that. And then I found this random, open source project.
I think on Mac, I use a thing called Shark, which, like many things on Mac, had a beautiful interface.
So is it Shark? There were a whole bunch of these. The Safari team, which I worked on, even wrote one, like a sampling profiler.
On Linux, I was very happy with pprof because pprof would produce basically a graph that you could load in GraphViz. And what was amazing about it, it was this great mix of top-down and bottom-up profile at the same time. And so you could find the like middle nodes in your compute graph that were heavy. Whereas if you see both in top-down or bottom-up, you get to find things that are sort of close to those ends of your program. And it's hard to find the things in the middle that are actually the heavy things.
So I don't actually know how to like easily rerun this thing. I think I just close it and open it again. I actually think this doesn't look very different of a profile. Is there a diff? Yeah, this thing doesn't seem fancy enough to have diffs. We can see if our thing. Oh, you know what? We never rebuilt.
Oh, well, that'll explain why it didn't move the profile very much.
One of the other things I remember doing with you is just building out profiling tools. We've talked about this before on the show about how that these things are all just too complicated and you have to build machines to do them. But I definitely remember with you like teaching our test harness how to call out to the profiling tool.
Mm-hmm. Yeah, like sample right now. Like find out what is on the stack when I'm in this function that's really hot that is just smashing two integers together, because I need to figure that out. Or like another one is we built it became very important in the web engine to optimize string memory. And so we built a specialized analyzer for the string heap that knew all the details about how string memory worked. And it could produce these like beautiful analysis of your string memory. And we went and found all of the redundant string memory in like a big app like Gmail and just like eliminated all of it and like fully optimized it. And it involved like very like subtle things like handling data URLs correctly, because data URLs can be huge because they can be like base64 encoded images. And like if you have 2 copies of this data URL, you're just gonna like eat memory like crazy.
All right, let's see. How'd we do? All right, not surprisingly, what's this inclusive percentage? I don't know what the exclusive percentage is. Does it have a hover?
But it went down. It was at like 35% before, right?
Well, let's see if our thing dropped off the.
That was on call stacks, right?
Well, so these are Alex. We now have one format. Let's see where this one comes from.
Run frame in fiber.
889.
But the whatever line of code we were looking at is not totally gone from this.
Well, let's see what the. Oh, I see. So these are top call stacks? Like, are these views related? Oh, okay. So what's this?
I see.
I think we made it go away.
I think we killed the #1 call stack for malloc.
Whoa, there's a format inside minus?
Well, that's worth looking at.
Yeah. Okay. So let's go look at num minus. Num minus. Honestly, I love this stuff. I could do this all night.
I mean, looking backwards from malloc is usually a good thing because malloc is a pretty heavy operation. As you see, it's the #1 operation in this program. It also tends to be quite easy to optimize because often you can just get rid of it entirely.
All right, so validate num. Okay, here we are again. Here we are again. We're eagerly formatting something.
So what is trying to num? Is that something you wrote?
Yeah.
I see. So maybe we should change that to take a closure of the message instead of the message itself.
It's not actually clear that trying to num is actually needed anymore. This was my earlier attempt. So one of the other things that I did, this is actually where most of the passes came from, is that I taught Wren Rust how to spit out reasonable error messages, because so much of the tests for error messages.
What does it mean? Result? What is result? What I'm used to result taking 2 template parameters.
Aha.
I'm surprised to see it take 1.
This was a tip that I read on the internet, and I've only applied to this one file.
Oh, you created an alias that.
Yeah. I think this is super sexy. Like
you're sort of trading readability for terseness, which I don't know.
Oh, I like this. But okay. But yes,
fair enough.
It basically says that in this file, result defaults to VM error as its error type.
Okay.
But okay, I can understand if you question the trade-off. In any case, validate num. Basically, try into num is a foot gun. All of these try intos are now with them taking a string.
Mm-hmm. I'm just thinking about what the right way of what a good way of fixing this is. Like, I kind of wonder if this thing should return the error first, and then you should decorate the error in the caller with sometimes you have the opportunity on the way up the call stack to decorate your error, right?
Mm-hmm.
Like, what if this just returned option instead of consuming the error?
This is the only caller of trying to num.
Yeah, but I just see you have a bunch of these. This pattern is trying to everything. Like we could apply the same pattern everywhere.
Mm-hmm.
Like it's not really, the error path is not really adding any value here. Like what if this just returned option F64? 64.
I agree.
Should we try it?
Yeah, let's try it. And it's easy to do now because we can edit one at a time. You doing this or am I?
Yeah, go for it.
So it's like, this is some, this is none. Right?
Mm-hmm.
Oh my God, these dark arrows are gonna bother me, but that's fine. Mismatch type. Okay. Yeah. So now this is gonna be
value trying to num, okay, or else, and then your thing.
oh. I'm not, like, isn't that making a new closure every time it comes into this? Or is Rust like smart enough to not?
I think this thing will get, I think it'll probably get inline. What do you might guess? And we can look at the, so another thing I do in performance optimization is a program called Godbolt, or a website called Godbolt, that you can type in source code to, and it will show you the compiled assembly for it. And then you can often see like how does, so like I would just go look and see how does this okay or else pattern get compiled by the compiler.
We're a few steps ahead. Like that's another thing about profiling is that you want to start with the, like, I think we could probably spend the entire episode just on like the low hanging fruit in this.
But a part of it is recognizing the pattern, right? Like now we've seen this in a couple different places where the pattern is deferring error path work off the mainline execution. And then you might want to think about like, what is, like, how do I build a good ergonomic machinery for that? And then like, clearly if that's important, I should look at the disassembly of it, figure out exactly what the optimal way of doing it is. It balances expressiveness and terseness and all this stuff.
Yep. You can also start by asking Stack Overflow what like proper pattern is too. But yes. But no, I agree.
Should we fix all of these try and twos? Like that's another thing about these profiles is like the profile will point you to like the one particular one that's burning hot, but often if the pattern is repeated, sometimes it's better to just adopt the better pattern in all the places just for consistency.
I want to see it drop off first.
Okay.
So again, in other profilers I've dealt with, you can just like rerun.
Did you compile?
I did.
Okay.
But this should make the format drop off of our. I don't see format. Okay. So I agree. There is a question like, what is the right? But yeah, I don't think this is adding any value here.
I mean, you can even make a smaller, like.
Honestly, if anything, we make these into a macro.
Mm-hmm. You're in love with macros.
Well,
that's great. The macros in Rust are super powerful. Like I get afraid of them because in C++ and C they're just like disastrously dangerous. But in Rust they actually like correctly do scoping and like
try into, and then we want this to be. Oh, except we need the like paste thing.
Oh, you haven't teched up to the paste crate yet?
I haven't.
You can just pass a few different, like more inputs.
That's fine. We pass the whole thing. We try into num, and then this thing takes. I did copy pasta here, as you see. Self. And this is option. And then this is going to be. It's an expression. Is it our types?
They're identifiers. You just want an identifier, right? For this, you're talking about like string.
Turn.
They need your enum.
What'd you say?
You need which of the enum values you are.
What does that mean?
You'll see in a second once you copy.
Oh, yeah, exactly. You're going to need, and then this is value type or something like that.
Which is also an ident.
And this should be able to be written as try into, which if we take it with paste will go away. This is F64, and this is num. I suspect it should be flipped. Making more sense like that.
I want this to be pub.
And does this have a semicolon after it?
Well, no semicolon.
Okay, what's going on? Why is it sad at the world? Must be delivered in braces followed by a semicolon. Okay.
You have a comma here at the end that you don't want.
No variant associated with value type.
You need a $sign.
Yep.
You don't want both of these, right?
Yep. I was just keeping it until we knew that the fancy one worked. And now we spam.
Spam.
String. And this is string. And this is string. All meaning different things. Oh, this isn't actually going to work. Right? Because they have. So I think we need to do a second example, right?
Oh, they're all clone except for those first two. So.
Yeah, so let's look at this one. So maybe these first two are the wrong ones to do.
Yeah.
So if I delete this and leave this.
All right, so let me change this to clone. Use it for the rest of them.
And really, this gets back to, so one of the things we attempted last week, I think, is abstracting this into a like a reusable pattern. Sorry, like a
handle. Yeah, there's something not quite, like there's something slightly more generic that you could do here. That's being covered up by this macro. Oops.
Yeah, if we just had we could use dynamic dispatch.
Couldn't quite figure out how to do it though. There was some like tricky thing that we couldn't get past.
Yeah, we didn't quite get there. Oops. All right, so range.
This is range.
Sure.
I think it the. I feel like class and object class are backwards here.
The return type is the last one. Map, which is going to be map. Oh, you already did map.
I think this parallel editing is not actually making it more efficient. All right,
Really?
let's let you finish. I'll let you do it. It's entertaining to both try to do it at the same time, but it's a little bit too.
We need like
parallel code
more
as well.
verbal communication, like on the basketball court. This is
Pass left, pass right. Obj, map, class.
I don't know if this is ob function or object then. Okay.
We totally got map twice. It's cool. We got this.
Professionals.
We also have class twice.
Okay. Instance. And do instance. I think we went off on a yak shave here a bit.
Yeah, I mean, I'm not sure it's good television to go do all these things, but it's the way I would actually do the project is I would go and clean up the
Just to
pattern
fix it if you see it.
Yeah.
Yeah. There is definitely some of that.
You've seen programs that have only been micro-optimized, where like there's clearly like the golden path that's been very carefully curated, and the rest of it all has this like ugly guts hanging out, and you can tell that it's like, you could widen the path a little bit so that you don't always just hit the good path in your benchmarks.
Okay, so now we need to flip these.
But you can make a macro for this too if you want to go macro crazy. Because a macro, you can actually control the evaluation order, unlike a normal function.
You mean for these? So as this comment says, Wren just does these blind casts, which we don't do, and maybe we'll eventually get to doing. So instead, I followed the pattern to have some prayer of ever doing that.
I mean, you could do that. You could just say, try into range unwrap, and there's your blind cast.
Oh, really?
Yeah, if you don't want to handle the case where it might be none, the option has an unwrap method that will panic your program if you're wrong. But if you're right, we'll just give you the answer.
Well, that's what we should just do. Like,
or actually, in the case where you want to have a result, you just return, I think it's just okay. Let me check and see what it is.
These don't need error messages here, but yes, I think try and unwrap. You're right. Now that it's option makes a lot of sense.
Yeah, unwrap will just give you the actual thing, so you won't even get a result here. So you can just take the result away from the return value.
Oh. For this ones, I think that makes sense. Okay, parallel editing. We got this. Okay, this is looking good. I like the moving away, moving the error to a different place.
We also changed the type of the error, right? Now the error is like your interpreter crashes.
Yeah.
Which is safer than it would be in C if you did a blind cast. Like then you probably get undefined behavior. This is defined as program panics.
List. Like these don't need to extend themselves.
Because there's some other non-local invariant that ensures that this is always correct.
Correct. That you have to do in order to conform to the test suite. You have to like make it so you cannot ever inherit from these. Try and string, really?
This is going to generate more errors elsewhere.
Yeah, we kind of went down a rabbit hole here. I like where this is going. I do think this is making the code better. And as you said, it's an honest.
But that's always a good question to ask yourself, right? When you do a performance optimization, am I making the code worse in order to make it faster, or is really making it faster making it better? Mm-hmm. And I think the ideal performance optimization also makes the code better by making it tighter or like more precise or prettier or something.
Okay, so that one we want to keep. These are all the ones that are now dropping their result. And the reason why I put them in a function that was named this as was to make it very obvious.
Because you thought you might want to do this optimization later. This is another trick I do often is I pick when I'm choosing a name for something or a lexical structure, if I know that I want to return to all these things, I'll give them some very searchable name. I just did this today, actually, where I had a thing that I would always call name, but I knew that these instances of names were particularly interesting, and I would probably want to come back to them. And so I called it local name, which is a little bit more verbose, but also an unusual kind of identifier that I can go find again. This is all like downstream hackery of working in C++ for many years, is that modern languages like Rust and Dart and all these things have much better support for analysis. Like you can often click on an identifier and say, okay, find me all references of this identifier, not necessarily the ones that are lexically identical, but the ones that are actually referencing to this. And I still have some maladapted habits from C++ not having that.
Part of it was also to make it really obvious if you ever called this, like I wanted the caller to not be able to do it for an arbitrary type. Like one of the things I didn't like about the C code was that you just had this blind cast. You could just do as class, and it would just take whatever you passed at and be like, yeah, I'll treat it like a class, and then have undefined behavior if it was wrong. Okay, but all right, so I think we may just be down to the few of these. So these are real casts where we want to throw errors.
Yeah, they were just, yeah.
But I think you had said before, it's like, it's or, okay, or else.
Mm-hmm.
And then it's this, and then it's VM error from stir. That's another thing I don't understand about Rust is when to use stir versus string.
Yeah. So, I mean, you know the difference. So string means it owns its backing buffer, and stir means it's a slice that somebody else owns the backing buffer for.
I understand that difference. I just don't know, like, idiomatically when. Sometimes I feel like if I'm going to end up owning it, I should declare my arg as a string to be like, hey, create something that you pass into me, like to force the caller to do the creation instead of like taking and doing the into myself.
Yeah, in my project, I just sort of established patterns for it where it's like that, right? If you're going to eventually store this thing and you were going to make a copy of it, try to push that copy all the way up the call stack as possible, because it's possible that the person who's calling you can just donate their version and then you can skip the whole copy. But these are also like micro optimizations that I'm not sure actually matter. Or maybe they matter.
Your profiler.
When the profiler tells you they matter.
Then you know.
What I like about Rust is it gives me the opportunity to make those kinds of choices, even if I find they can be overwhelming in the case where I don't need to know them. Like in many cases, I don't care. I just want it to like take my damn string and do something with it. But there's some cases where like I really want to know like what is happening with the memory behind this string.
Okay. Function takes 0 arguments, but 1 was supplied. This thing again. We're really close. Okay, or VM error. Okay. What did I do?
One more close parenthesis before the question mark.
Okay. Another one. Try into closure dot okay or else. VM error from string format. A bunch of the standard library stuff take they have like macros. Like this VM error could be a macro that like took like format args. A bunch of the standard library stuff does that.
Yeah, you see that often with stir and string, where somebody's put a lot of work into their library, will give you lots of different options. We're like, okay, do you have the string? You want to give it to me? Do you have a slice? Like it becomes very flexible. When I'm writing my own code, I don't really have the time or the inclination to type out every variant that somebody might want. I only type in the ones that actually occur in my program.
Okay, how do we do? Okay, why is this ignored? What is this? This is expect class. I see. So this just
So you can do the same thing.
Mechanics, right?
Yeah, so this is just fine. You can option has expect also. So you can just delete the. Oh no, you still want that function. You can just delete the argument to it.
Oh yeah.
Mm-hmm. So this is an example of this pattern clearly making the code better.
Trying to class. Yeah. Okay. Error from string. What do I do?
I'm sure you just need another parenthesis. I haven't actually counted the.
That's always the solution.
But whenever the formatter doesn't like reformat your code, you can tell that it's missing a parenthesis somewhere.
Yeah. It is one thing I think Rust could do a little better. I mean, it's really hard, but I do think that it would benefit from having a more forgiving, better error recovery for its error generation.
Yeah, I mean, I always wanted the compiler to just fix it. It's like, you wanted a semicolon here. It's like, cool. And why do I have to type it? Well, you're the computer.
Has integration for some of that. I think the Rust analyzer and stuff just doesn't do it yet. I think you're right. Like, this was the time when figuring out exactly what the right pattern, giving a little more thought before we splatted these all out like this. I have 13 more of these. Maybe message.
Ignored. So just another good example of a unwrap. If that's what you want to do. Yeah, unwrap or there you
go. I think this is an actual. I don't know. This is where I would go look at VM. Oh, I see. They have an assert, so this like crashes.
Yeah, that's essentially what your unwrap will be like.
It doesn't really matter what the error is here. That's what I'm saying.
Because it's going to crash. Or you want it to crash.
Well, I don't need to like throw a fancy error here, right? I just unwrap.
Yeah, I mean, you put the expect if you want a very similar behavior to what you had before.
Sure. You expect. But like, this doesn't matter. That's only for my own sanity and debugging when I fed the thing something that's not valid.
Yeah, which is also valuable.
That's another distinction between like runtime error and programmer errors. And assert should be for programmer errors.
It was my fault as the VM author.
Mm-hmm. So this is okay. Else.
We require more Vespian semicolons or parentheses. Should I explain the reference? So this is
sure.
This is from back when we used to watch a lot of StarCraft. We used to watch a lot of Korean high-level StarCraft, and the little workers in this game. There's the minerals that you can mine, and then there's the Vespian gas. There's another resource you have to mine. Yes. And when you try to build a unit or build a building, you don't have enough gas, and the game tells you we require more Vespian gas. And so it just became a thing that we say whenever you need more of something.
This is when we were all living together. And yes, watching Korean StarCraft. Okay, what am I doing again? It is so hard to talk and write VM errors at the same time. Four. We're down to 4. What is this?
It also looks like it might be an assert.
I think this is more where the VM. VM. Yeah. It just is like, you're a class.
That's class. I know it.
Yeah, whenever it's not nicely punctuated and stuff. Check arity. I think this is another one. Yep. Assert. Trying to closure. Receiver must be closure. I only recently started adding all these error messages in. I was starting to try and comply with expectations. Okay.
We did it, team.
We did it. This is the kind of thing where like you feel like you need to run the tests. I think that was basically the show, anyways.
Can we compare our before and after score on the benchmark on the?
Sure. I don't know that we can do it. I don't know that we saved. We can go up in the history and look. I mean, it feels faster already. Here, let's scroll back in time here and see if we can find it. So Wren Rust.
Binary trees, 5.66 seconds.
This is our before. Or after.
Whoa, look at that.
Halved it.
Halved it. More than halved it. There you go.
Yeah. Low hanging fruit.
Yeah, like to take all the mallocs out, double your speed.
Yeah. I think this is like an area of computer science that just isn't that commonly needed. Because more often it just matters whether something works than whether it's fast.
Yeah, you're often working with like a huge performance envelope. But I think like a language runtime or a compiler is a thing that is often worth this kind of effort to make go fast.
Well, I mean, you think about the infinite hours that have been spent making JavaScript fast.
Yeah, I mean, there are whole tech levels where like this approach will get you so far. Then there's another approach where you like refactor and restructure your code. And then there's like, okay, we need a whole new approach, like a JIT or an ahead of time compiler or like new tech levels entirely. Well, I would also be interested if you look at the other scores that we get and the other benchmarks, because we only profile this one benchmark. Yep. I'm curious like how much it cross-cuts across all of them.
Significantly. Like you can already see. Right? Like our fib score is 1/3. Like we have not even begun to play here yet, right? We did super low-hanging fruit. And we cut benchmark times by 1/3. Well, binary trees, it's only at half. But this probably because binary trees is some other super low-hanging fruit. Like I think, we're out of time here, but like this, I suspect is going to show us that allocating the stack or the frame or something like that, it spends a bunch of time. We'll have to look and see. But anyways, that's for another show.
That's pretty impressive, like the speed up. I think that's great.
Anyways, it was fun to me to reminisce, if nothing else, because this is like literally what you and I used to do all day, every day for the web.
I spent an entire year doing this for like graphics performance. Like looked at all kinds of benchmarks and everything, and like knew that engine inside and out, where every second went everywhere. Like, it was fun. I enjoyed it.
I think we talked about this on the show, but I just remember, doing things like running the Chrome engine across the entire, not the entire web, because the entire web is basically infinite. Like it just it spirals into who knows what generated content pages, but like, over 1 trillion web pages or something, or 1 billion web pages, and just like looking at the slowest one.
We'll look at the crashiest one.
Or the crashiest one, or the who knows what one. And
the slowest one is amazing because it's always some outlier. Like I remember it was some like horrible, like one time we did this, it was some horrible table layout bug that was like n-cubed table layout, which no one even knew was possible, but it turns out.
Well, and then you fix the outlier, and then just like you saw tonight, you move all of the, and it matters that you moved, every page by 1 millisecond, but you just couldn't see it in those other pages.
It turns out that n squared is like really big when n is big, but it's also big when n is sort of moderate, even though it doesn't like bring your browser to its knees. It's still like a noticeable effect.
Anyways, so we were trying a new segment last week of things you learned. Do you have a thing you learned?
Yes, I learned something today. So I'm working on file descriptors and mount points and current working directories and things like that. And so I learned that in Linux, if you like open a directory and you get like a file descriptor to it, I had this question of like, okay, what happens if while I'm holding this file descriptor, someone else comes along and mounts something like another file system on top of this directory? Do I see the new thing that got mounted here, or do I see the thing that I was holding on to like before the mount? And the answer is you see the thing you were holding onto before the mount. And so if you go back and take your thing and turn it back into a string and open it back up, you'll get a totally different thing because you'll get the inside of the mount.
Okay.
I assume they made this choice for some sort of security reason. Like once you open something, you don't want somebody else to be able to come in behind you and mess you up. And so you want to like really lock on to the thing that you've opened really tightly and stop interference from even root mounting things.
Well, it feels like it matches how other bits of Linux or of other like file system access, like if you open a file, what happens if somebody else writes to the file?
You hold on to it, even if they move it around or the file system or,
Oh, you hold on to the open, but like the contents of the file, right?
If somebody writes it, you'll see you're racing with them. So you'll see the race of their contents.
I see.
It's counterintuitive for me because in the web, if you have an iframe and you grab the window of that iframe, and then that iframe navigates somewhere else, your window now refers to the new thing because you're holding the outside of the mount point as opposed to the inside of the mount point. It actually turns out
you like the window object into the like inner window and the outer window and
this is a great source of like security vulnerabilities in browsers for a while, is the confusion between the inner window and the outer window object. And you have to like get it exactly right. Otherwise, you might end up with a reference to some web page you're not supposed to, and then you can attack them. And
there was another year of your life.
Oh, that was more than 1 year, my friend.
Oh, well, I don't think I have a computer learning this week. I mean, I learned a whole bunch about installing Windows profilers. Let me tell you that. None that's good to regurgitate. I did learn that jalapeno cheese bread is delicious.
I can believe that. That sounds plausible. How did you come to learn this?
Oh, well, so we had some friends coming over for it was like the 4th or whatever. So last Monday, because we had off, I baked some bread and I asked them what kind of bread they wanted because I wanted to, try something different. And they suggested they wanted jalapenos in their bread. And so I went and bought pickled jalapenos, which I'd never bought. Also delicious.
Oh, pickled jalapenos. Neat.
Pickled jalapenos. The recipe said to put pickled jalapenos in because they had a stronger taste. More jalapeno-y, whatever.
Did you have to like compensate with the salt in the bread because of the pickling, or that wasn't a factor?
It didn't turn out to matter that much. The salt in the bread, I found is actually, I think, less about the taste because I don't really taste it, but it does really change the chemistry of the bread. If you forget the salt in your bread, it will not come together right.
But the jalapenos the pickling was not enough to upset the chemistry of the bread.
No. All the stuff when you add stuff into the bread, you add it kind of late, like after the bread is like starting to do its thing, and then you like mix it in at the end. So
I see. The interesting chemistry has happened already. That makes sense.
I think so. Yeah. It's actually interesting when you do sourdough. They discovered probably 100 years ago or 200 years ago, not 2,000 years ago, that if you leave the flour and the water, the flour and the water and the yeast together for a while, they call this autolyse or something like that. It actually helps it do better bread chemistry, and then you add the salt. So you add the salt in a separate step, but then you add add-on stuff much later in the bread. I'm only 100 or a couple hundred loaves in. I'm not like an artisan yet, but enough that I've memorized the steps. So
that's further than I am, I'll tell you that.
Anyways, it was fantastic to see you. It was fun to do some profiling and some refactoring, and I agree that the suggested modifications made the code a lot cleaner. And it was wonderful to see so many faces today. Giphy asked about an hour ago about a Flutter demo on Fuchsia. I mean, one can see that oneself running one of these Google Home Hubs. At least that's what the news tells me.
So someday we'll do a demo like that. But we'll let you know on Twitter. If you follow Rubber Duck Eng on Twitter, you'll find out the scoop about what's happening with the show schedule.
Yeah. Anyways, as he alluded to, send us your feedback. Otherwise, we'll see you next week.
Yeah, see you next week. Thanks for joining us.